myself, Dr. Ashok Babu, working as professor and head EC department. So in this video, I am going to discuss about some problems in electrostatics. So we'll see the first problem. So the problem is a point charge of 5 nanocoulombs is located at origin. So if potential V is equal to 2 volts at 0, 6, -8, then find the potential at A -3, 2, 6 and the potential at B 1, 5, 7 and the potential difference between A and B, VAB. So here we know the potential formula. We have general potential formula. V is equal to, it is Q by 4 pi epsilon naught R, and there is C is some constant. So here the potential, if the potential at infinity is 0, in problem if it is mentioned that the potential at infinity is 0, then we can assume the constant C is equal to 0. So otherwise we need to find out the C value. So here the formula for potential is, it is V of R equal to Q by 4 pi epsilon naught R plus C. So here we, the potential at 0, 6, -8 is given as 2. Therefore substitute in the formula. Therefore the potential 2 is equal to, the charge Q is given as 5 nanocoulombs. Therefore 5 into 10 power minus 9 by 4 pi epsilon naught. Epsilon naught values 10 power minus 9 by 36 pi into. So here we need to find out the distance. So here the distance is 0, 6, -8 and between origin. Therefore it is 0 minus 0, 6 minus 0, -8, 0. So if you find out the magnitude, it is 0 square plus 6 square plus 8 square. So it is root of 36 plus 64. So root 100. So the distance is 10. So if you substitute the distance, then it is 2 is equal to 5 into 10 power minus 9 by 4 pi into 10 power minus 9 by 36 pi into the distance is 10 plus 6. So here if you simplify the expression, 4 into 4 9 times. So it is 10 power minus 9, 10 power minus 9 cancel each other. Therefore we have 2 is equal to, it is 45 by 10 plus C. Therefore it is 2 is equal to 4.5 plus C. And the C value, C is equal to 2 minus 4.5. Therefore C is equal to minus 2.5. So the value of C is minus 2.5. Now we need to find out the potential at point A -3, 2, 6. So here we can find the potential at -3, 2, 6 as we are by using the known formula. So the potential at point A is VA. VA is equal to, it is Q by 4 pi epsilon naught, same as the previous one, and we need to find out the distance between -3, 2, 6 and 0, 0, 0. Minus, we need to substitute the C value as plus C. It is actually it is 2.5. Substitute the C value also. Therefore, if you find out the distance, it is, the distance is -3, 2, 6, and if you find the magnitude, it is -3 whole square plus 2 square plus 6 square. For it is 9 plus 4 plus 36. It is root 49. So it is 7. The distance is 7. So if you simplify the expression, the voltage at potential is the voltage at point A, the potential at point A is VA is equal to 3.929 volts. Similarly, we need to find out the potential at B. So the potential at B is 1, at the point is 1, 5, 7. Again, we need to find out the distance between the 1, 5, 7 and origin. Therefore, 1, 5, 7 and the origin is 0, 0, 0. So therefore, the distance is 1, 5, 7. So if you find the magnitude, it is root of 1 square plus 5 square plus 7 square. For it is root of 1 plus 25 plus 49. So it is root of 75. The distance is root 75. So substitute the values and find out the potential at point B. So it is 2.696 volts. So here we need to find out the potential between A and B. The potential between A and B is VAB. VAB is equal to VB minus VA. Therefore 2.696 minus 3.929. So the potential between the points A and B is minus 1.233 volts. So this is about the procedure to find the potential. Next one, we'll see the next problem. So here the 2 point edges Q1 and Q2 are located at 4, 0, -3 and 2, 0, 1. So here the distance of the point Q1 is R1, let us assume R1, which is placed at 4, 0, -3, and the distance of the point charge Q2 is 2 comma 0 comma 1, which is placed at a point R2. So here if Q2 is equal to 4 nanocoulombs, and we need to find out the Q1 value. So we need to find out the Q1 value for the two conditions. The two conditions are, we need to find out the electric field intensity at point 5 comma 0 comma 6, which has no Z component. And the second condition is we need to find out the Q1 value, where we need to find out the force on test charge of 5 comma 0 comma 6, which is having no X component. So for these two conditions, we need to find out the point charge Q1. So here the formula to find the electric field intensity is, it is E is equal to, we know the formula, Q1 by 4 pi epsilon naught into AR by R square, or E is equal to, is a Q by 4 pi epsilon naught R cube into vector R. So here in general it is E is equal to Q into, it is R minus R1 by 4 pi epsilon naught into modulus of R minus R1 whole cube. So this is a general expression to find out the electric field intensity. So if you need to find out the electric field intensity at a point 5 comma 0 comma 6, then if you substitute into formula, the first one is Q1 by 4 pi epsilon naught into the point R is here, the distance R is 5 comma 0 comma 6, and the the point charge Q1 is placed at 4 comma 0 comma minus 3. Therefore, the distance between 5 comma 0 comma 6 and 4 comma 0 comma minus 3 is, so it is 5 comma 0 comma 6 minus 4 comma 0 comma minus 3 by, so modulus of 5 comma 0 comma 6 minus 4 comma 0 comma minus 3 whole cube. Similarly, we need to find out the distance between the other 2 points, 5 comma 0 comma 6 and 2 comma 0 comma 1. So this is the second one. So here we need to find out that Q1 is unknown value, Q2 is the known value. Here the condition is to find out the Q1 is, so here there is no Z component. So here there is no Z component means along the Z component we have the electric field intensity. In other two directions, that is perpendicular to the Z like X and Y components, we don't have the electric field intensity. Along Y, X and Y, the electric field intensity is 0. Along Z, we have the electric field intensity. So no need to consider the X coordinate and Y coordinate. So here X coordinate is 0, Y coordinate is 0, and here X coordinate is 0, Y coordinate is 0. Therefore, the equation can be reduced to, and equate the electric field intensity E equal to 0. Therefore, the expression can be reduced as 9Q1 by 4 pi epsilon naught into, so if you find out the distance between these two, it is 5 minus 4, comma 0 minus 0, then 6 minus of minus 3. So 5 minus 1, 5 minus 4 is 1, comma 0, comma 9. So if you find out the distance between these two, 1 square plus 0 square plus 9 square. So 1 plus 81, it is root 82. Similarly, we need to find out the distance between the other 2 points. That is 5 comma 0 comma 6, 5 minus 2, 0 minus 0, 6 minus 1. So it is 3 comma 0 comma 5. For the distance here, magnitude is 3 square plus 0 square plus 5 square. It is 9 plus 0 plus 25. It is root 34. So in this way, we can find the distance between these two and equate it to 0. So then if you simplify for Q1, the Q1 values, if we need to substitute the Q2 value. So here Q2 value is given as 4 nanocoulombs. So substitute the Q2 value, and the Q1 values, it is minus 8.3232 nanocoulombs. And second condition is, we need to find out the force at 5 comma 0 comma 6, and while finding the force, we need to assume that the X component is 0. So the X component is 0 means in X direction we have the force. In remaining two directions, Y and Z directions, we have the force is 0 and electric field intensity is 0. Therefore, we need to consider the only X component. So here, if you assume the X component, here we have 1 in first charge and Q2 3 in second charge. Therefore, 1 Q1 by or Q1 by 4 pi epsilon naught into 82 whole power 3 by 2 plus 3 Q2 by 4 pi epsilon naught into 34 whole power 3 by 2 is equal to 0. Therefore, again, if we equate it to 0 and substitute Qd is equal to 4 nanocoulombs, we have Q1 is equal to minus 44.945 nanocoulombs. So this is a procedure to find out the unknown charge while X component is 0 and Z component is 0. The next one is, so a ring is, the next problem is, a ring is placed along the x square plus y square is equal to 4. A ring is placed along x square plus y square equal to 4, comma, x equal to 0. So carries a uniform charge of minus 5 microcoulombs per meter. Then we need to find out the D8, electric flux density at point 0, 3, 0, 0. Then second one, if two identical point edges Q are placed at 0, minus 3, 0 and 0, 3, 0. In addition to the ring, we need to find out the value of Q such that D is equal to 0 at P. So first one, we need to find out the electric flux density of a ring dr in first condition. In second condition, we need to find out the electric field in electric flux density due to a ring plus the point charge. So after finding the electric flux density due to ring and point charge, we need to eliminate the Q. To eliminate the Q, we need to assume dq plus dr equal to 0. So this is the actual procedure to find out the given problem. So here it is a ring is given which is having the radius A, and the distance between this point current element. Let us assume here it is some current element ideal is there. So the distance between the current element and electric field density is some r. So like that, assume a figure. So here we know that the electric flux density formula is D is equal to integral rho L dl into vector r by 4 pi r cube. If it is a line charge, if it is a surface charge, so here we can write integral rho L ds into rho s ds into vector r by 4 pi r cube. If it is volume charge, here we can write the formula rho v dv into r vector r by 4 pi r cube. So these are the two formulas to find out the surface charge and volume charge. So here we need to find out the distance between the 2 points. So here we can find out the distance between the 2 points is, it is xax, actually distance is xax plus yay plus zaz. Next, so here in place of xax plus yay, so here I am assuming because rho is equal to, we can substitute rho equal to x square plus y square. Therefore, we can substitute in place of x comma y, we can substitute the rho a rho plus z a z, and the rho in place of rho is the radius. Therefore, because a is the radius, here we can write a into a rho plus z a z. So here from the figure we can observe that the r is along the upward direction and the radius is toward downward direction. Therefore, here I am assuming negative to the radius. So minus a rho minus a into a rho plus zaz is the distance between the 2 points. Then if we substitute the same in electric flux density, the electric flux density D is equal to, we have rho L by 4 pi sigma phi integral phi equal to 0 to 2 pi. So here it is in place of rho L, or dl, in place of dl, because it is a ring, here we can substitute the rho into d phi. Rho L equal to dl equal to rho into d phi, but rho is the radius of the circle. Therefore, we can substitute dl is equal to a into d phi. In place of rho, here I am writing a into d phi. Therefore, a into d phi into minus a into a rho plus haz is a vector by, so magnitude of the vector, magnitude of the vector is root of minus a square plus z square. Therefore, a square plus h square whole power 3 by 2. So here z is along the length along the z axis. So here h is the length along the z axis. Therefore, here we can write minus a into a rho plus haz. Therefore, here the distance is a square plus h square whole power 3 by 2. Next. So here, due to the symmetry, here a rho equal to 0. Due to the symmetry, here we can substitute a rho equal to 0. So here, if a rho equal to 0, then we have the expression D is equal to rho L by 4 pi into phi equal to 0 to 2 pi. So here it is a into d phi h Az by A square plus H square whole power 3 by 2. A square plus H square whole power 3 by 2. So here A and H both are constant. Then therefore we can keep outside. So here we need to integrate the equation with respect to 1 into d phi. Therefore d is equal to, here we can write rho L by 4 pi into A by A square plus H square whole power 3 by 2 A into H integral phi equal to 0 to 2 pi 1 into d phi Az. 1 into d phi Az. Therefore it is 2 pi. Therefore you can write d is equal to, it is rho L by 4 pi into AH by A square plus H square whole power 3 by 2 into 2 pi. 2 pi cancel each other. You have 2. Therefore the expression is rho L into A into H into Az by 2 into A square plus H square whole power 3 by 2. Now we need to substitute the values. So here the radius A equal to and height H equal to 3 and rho L equal to 5 microcoulombs per meter is given. So here if you substitute the values is D equal to 0.64 AX microcoulombs per meter square. Now we need to find out the first one. Second one, we need to find out the dr plus dq, and which is equal to 0. We need to find out the electric flux density due to point charge. So here there are 2 point charges as given. So the electric flux density due to 2 point charges, it is R, R1, R, R2. So it is Q by 4 pi into R minus R by, the formula is D is equal to, we have Q by 4 pi modulus of R vector by 4 by R. Therefore, if you substitute into expression 3 comma 0 comma 0 minus 0 comma minus 3 comma 0 by modulus of 3 comma 0 comma 0 minus 0 comma minus 3 comma 0 whole cube, plus similarly q by 4 pi into 3 comma 0 comma 0 minus 0 comma 3 comma 0 by modulus of 3 comma 0 comma 0 minus 0 comma 3 comma 0 whole cube. So if you find out the distance between these two is it is 3 comma 0. If you find out the magnitude, it is root of 3 square plus 3 square, it is 18, root 18 for both one. So here the total value dq is equal to 6q by 4 pi into 18 power 3 by 2. So now we need to find out the total electric flux density. The total electric flux density D is equal to dr plus dq, which is equal to 0. So here dr value is 0.64 into 10 power minus 6 and dq value is 6q by 4 pi into 18 power 3 by 2 is equal to 0. Now if you substitute all the values, then we can have the answer. Q is equal to minus 102.4 microcoulombs. Q is the value of Q is minus 102.4 microcoulombs. So in this way you can find the point charge, the unknown point charge Q. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.